So are we becoming cyborgs? With our smartphones, we have positive and negative aspects. We can have access to maps and information instantly. We can complete our business tasks much faster and much more efficiently. So these are the cybernetic superpowers that we can enable. The first one is inspecting batteries. This is for EV manufacturing. What we're actually doing is a technique called photon tracing. So there's a series of lights that move around the surface. We take the image from above, and the only place that a photon could arrive at the camera is from that point light source, the only place in the universe. As a result, we can compute material properties. This is the shininess, and then this is the normal map. So this is the surface 3D angles. And if we zoom right in, we can pick up this defect in the insulator. So that's just really, really hard to do as a human. You can do it easily now. This is a motherboard, so it has all of the normal shadows and reflections and complexity that we see as a human when we look at an image. And what we're going to do is we're going to deconvolve that. So this is the shininess. So all those numbers have disappeared because they are matte. And then this is the normal map. And what's amazing about this motherboard is there's a silk screen with printing on it. If we zoom in, you can see the edges of the ink, which is only 20 microns thick, and we can see how that ink folds over the edge of a copper trace on the motherboard. We're going to look at refraction, so that's bending of light through a subject. So in this case, we're looking for scratches on glass. The problem is there's condensation on the glass. Everyone can see there's scratches now, and amazingly, you can see the drop appearing just now. That's the drop you can see in the background, so that's a change in refraction over its surface. So this is a 19,000 times zoom. I'm going to zoom into a millimeter on a stainless steel ruler. That's the 7 and 8 millimeter mark. These are the 2 millimeter markings just above. So physically, on the 6,900 pixel wide stage, every one of those pixels you're seeing is 220 nanometers blown up to this scale. We can see the surface of the crystalline cold rolled stainless steel, and we can see where it's thermally changed its texture as it's recrystallized. So we can perceive molecular level items just using light. This is bovine IVF. On this image just here, we can actually see a sperm that's been trapped in the outside of the egg, whereas that sperm in there has made it in, and that's fertilizing that cattle egg. This is down to 220 nanometers per pixel again, so we can literally study the morphology of these objectively and in a much more scalable manner. So once again, giving us superpowers. All right, now we're going to see the invisible. This is acetone in a bottle, and you can't see anything until now. So this is the change in refraction, or the change in density of the air where there's a little bit of acetone in the air. This can also detect shock waves on the front of a plane wing, or changes in heat, and if you're looking at thermal expansion and you're trying to measure the flow of fluid in a gas in a volume. Hopefully it gives you a taste of some of the cybernetic opportunities in front of us.